In this video, we're going to take a look at what happens when we take different powers of I. So we already know, that I is equal to the square root of -1, I squared. So if we square this square root of -1, square rooting and squaring are inverse operations. So we know I squared is just -1. What happens if we do I cubed? Well, I cubed, using our properties of exponents, would be the same thing as I squared times I. We know that I squared is -1, so let's make that substitution. So that's the same thing as -1 times I, and that's -I. I to the fourth would be the same thing as I squared times I squared, which is the same thing as -1 times -1, which is +1. I to the fifth, that's the same thing as I to the fourth times I. Okay, very convenient to use I to the fourth because that's just 1, and 1 times I is I. Interesting. Notice I'm right back here. Let's keep going. I to the sixth would be I to the fourth times I squared, which is the same thing as 1 times I squared. And we already know I squared is -1, so this is -1. I to the seventh would be I to the fourth times I to the third. I to the fourth, we already know is 1. I to the third, we already calculated is -I. 1 times -I is -I. We'll do a couple more. I to the eighth is I to the fourth times I to the fourth. 1 times 1, or 1. I to the ninth, that's the same thing as I to the eighth times I. I to the eighth, we just calculated as 1. 1 times I is I. I to the 10th is I to the 8th times I squared. I to the 8th is 1. I squared is -1. And we'll see if I can fit in 3 more here. I to the 11th. I to the 8th times I to the 3rd. I to the 8th is 1. I to the 3rd is -I. So this is -I. I to the 12th, that's the same thing as, here we'll write it a little differently. I to the 4th times I to the 4th times I to the 4th, right? Or 1 times 1 times 1, or 1. I to the 13th is I to the 12th times I. I to the 12th was 1. 1 times I is I. So let's, if the pattern didn't jump out at you here, let's make it very clear. So our first one was I. I squared was -1. I to the third was -I. I to the fourth was 1. I to the fifth was I. I to the sixth was -1. I to the seventh, -I. I to the eighth, 1. I to the ninth, I. I to the 10th, -1. I to the 11th, -I. I to the 12th, 1. And then I to the 13th, I went to I. Notice the pattern. I went I, -1, -I, 1. I, -1, -I, 1. There's this nice cyclical pattern here, and your key is really these multiples of 4. The minute that you have a multiple of 4 with your exponent here, that's just going to be 1. And so all of these, this one here was I to the 4th. This was I to the 8th. This was I to the 12th. So anytime that your exponent is divisible by 4, you're at 1. So exponent divisible by 4. So as an easy example, if I wanted to know what is I to the 400th power, notice this exponent is divisible by 4. This is just going to be 1. Another way to think of this is you could rewrite I to the 400th power as I to the fourth, and then raise that to the 100th power, you would multiply these exponents to get this. And I already know that this I to the fourth is 1, and 1 to the 100th is just 1. So what about these other ones? Well, with this I here, my exponent was 1. This had an exponent of 5. This had an exponent. This one was I to the 9th. And this one was I to the 13th. So I to the 1st, I to the 5th, I to the 9th, I to the 13th, those were all just I. Notice what happens with these in terms of divisibility by 4. Anytime you divide by 4, you get a remainder of 1. 1 divided by 4 is 0, remainder 1. 5 divided by 4 is 1, remainder 1. 9 divided by 4 is 2, remainder 1. 13 divided by 4 is 3, remainder 1. So your answer is always going to be I if you take your exponent and you get a remainder of 1. If you're using a calculator and you're doing the division, you're going to see that a remainder of 1 will result in a 0.25 in decimal form. 5 divided by 4 is 1.25. 9 divided by 4 is 2.25. 13 divided by 4 is 3.25. All these negative ones, let's talk about those. So this was I squared was negative 1. I to the 6th was negative 1. I to the 10th was negative 1. If you take any of these and divide by 4, so 2 divided by 4 is 0, remainder 2. 6 divided by 4 is 1, remainder of 2. 10 divided by 4 is 2 with a remainder of 2. So anytime that you have a remainder of 2, you are going to have negative 1 as your answer. And if you're using your calculator, 2 divided by 4 would be 0.5. 6 divided by 4 is 1.5. 10 divided by 4 is 2.5. In decimal form, you're going to see a 0.5 right there. And you can probably guess your remainder of 1, remainder of 2. This one, all of these are going to have a remainder of 3 when you divide by 4. So this is I to the 3rd right here, this negative I. This negative I was I to the 7th. Notice that 7 divided by 4 is 1, remainder of 3. This was I to the 11th. I to the 11th was negative I. 11 divided by 4 would be 2, remainder of 3. If you're typing that in your calculator, the decimal here would be 0.75. So using this idea, what our remainder is when we divide by 4, we can calculate any power of I, and we can reduce it down to either I, negative 1, negative I, or 1. And my neat little trick that I thought of to help remember this is to think of this as I won, I won. Okay, I won, but then you got to get negatives in the middle. So I won, but there's negatives in the middle. So if you just write down that pattern, you'll be good to go in this. Just write I won, put negatives in the middle, and just remember that this will be your remainder of 1, this will be your remainder of 2, this will be your remainder of 3, and this will be your remainder of 0. We'll do some more examples of this in the next video.